Hello students. Till now we have studied about dual nature of radiations or light. Now this video is about dual nature of matter. So a French physicist de Broglie, the name written as DeBroglie, but it is pronounced as de Broglie, he put forward a bold hypothesis that every material particle which is in motion, then there exists a wave connected to that, or the material particle in motion should display wave like properties. And the reason for his consideration was, actually there were two reasons. First is the two physical quantities which are responsible for all the physical phenomena are mass and energy, and according to Einstein's mass energy relation, these are connected to each other by the relation E is equal to mc square, which show that there is a equivalence between mass and energy. So if energy has that wave nature and particle nature, so that's why matter should also have wave nature. This is the first consideration. The second consideration is symmetry. So he assumes that everything in nature is in symmetry. That's why, since radiation has dual nature, therefore from symmetry consideration he predicted that matter must also possess dual nature, right? So according to this hypothesis, in his hypothesis he put forward the statement that material particles which are in motion, we are considering only those material particles that are in moving state. So material particles in motion should display a wave like nature. At that time it was a hypothesis only, there was no proof to that. So this statement is then called as de-Broglie hypothesis, and the reason on which he proposed this hypothesis, so there were two considerations. Those two considerations were, first consideration was that the two physical quantities which are responsible for the phenomena happening around us, the two physical quantities responsible for phenomena that are taking place in universe are, that are happening in universe, these two quantities are mass and energy. And according to Einstein's mass energy equivalence relation E is equal to mc square, these two are equivalent to each other. So there is a complete equivalence between mass. Now mass refers to matter and energy refers to radiation. So this relation shows that there is an equivalence between radiation and matter. So as radiation show particle like nature or the dual nature, means radiation show both wave nature as well as particle like nature. This we have proved already as we have studied photoelectric emission, or we have studied the photon theory. So according to that, radiation possesses both nature. So similarly, since the two are equivalent to each other, matter should also show the wave like nature, or because of this equivalence there must be a symmetry, a mutual symmetry between matter and mass. This was the first consideration. The second consideration, or the uh, reason why he assumed that material particle in motion should display a wave like nature is the symmetry. So according to him, the nature loves symmetry, and this shows that, this reason shows that if radiation is showing dual nature, then matter should also show dual nature, right? So according to symmetry, as per the symmetry, if radiation is showing dual nature, then matter must also possess dual nature. So this is the reason we have. Okay, these are the two properties. On based of these consideration, de Broglie put forward his hypothesis that material particle in motion should display a wave like nature, or there must be a wave associated with every moving material particle. We can also state it like there must be a wave associated with every moving material particle. This is the de Broglie hypothesis. Now these waves, those are associated with the material particles in motion, are called matter waves or de Broglie waves. So these waves associated with moving material particles, these waves are known as matter waves. Since they are associated with matter, so we call them as matter waves or de Broglie waves. Since it is a wave, so we can put a wave equation for that, and that equation is called de Broglie wave equation. So now we are going to find de Broglie wave equation, and for that we are going to use two relations that we have already know. So we consider that photon is an electromagnetic wave of frequency nu. There is a photon of an electromagnetic wave which has frequency nu. So its energy, as per the Planck's quantum theory, the energy of that photon can be given as E is equal to h nu. Right, this is equation number 1. E is equal to h nu is the energy of the photon of a electromagnetic radiation with frequency nu, and h is the Planck's constant here. Now we consider photon as a particle of mass m. If this photon having energy E is equal to h nu, it behaves as a particle of mass m. Right, we consider this photon is of mass m. Then according to Einstein's energy equivalence, the energy associated with this photon is equal to mc square. So the energy associated with this photon of mass m is given as E is equal to mc square. This is equation number 2. Since these two equations represent the energy of a same photon, so we can equate these two, and according to this, h nu is equal to mc square, which gives us the relation hc upon lambda. I am writing nu is equal to c upon lambda is equal to mc square, or it can be solved into lambda is equal to h upon m into c. Now m into c is mass into speed or mass into velocity, which is the linear momentum, so h upon p. So lambda is equal to h upon mc or lambda is equal to h upon p. This equation represents the required de Broglie wave equation. Now the speed here in this case is equal to the speed of light, because the photon we have considered is of electromagnetic radiation or of light, and p is equal to mc is the momentum of the photon, lambda is the wavelength of the radiation of frequency nu. That radiation of frequency nu has the wavelength lambda, and p is its momentum. But according to de Broglie hypothesis, this property, this equation should be true for material particles also. Now material particles like electrons, protons, neutrons, etc. So according to de Broglie hypothesis, the equation that we have proved, lambda is equal to h upon mc or is equal to h upon p, that is for that electromagnet is moving with velocity v. So if we have a particle of mass m that is moving with velocity v, then as per the result, in this case the wavelength associated with that moving particle, or the wavelength of the matter wave that is associated with that moving particle, lambda should be equal to h upon mv or is equal to h upon p. Right, so this is the required wavelength of de Broglie wave that is associated with the moving material particle, and this equation is called de-Broglie waves equation, right? So this we have found as per the symmetry. Since this relation was true for radiation, so in case of moving material particle it will also valid with a change in velocity, because this was for light or electromagnetic radiation. In that case the speed is c, but in case of matter waves the speed of material particle is not c, it is something less than c, so we represent it by the velocity v. Now in this equation lambda is equal to h upon p. Lambda is the property of a wave, so wavelength here show wave nature, and p is the property of particle because it is the momentum of a moving particle, so p is showing particle nature. So de-Broglie wave equation is actually show a link between wave nature and particle nature, or it connect the wave characteristic with the particle characteristics, and that's why we say that the matter has dual nature, it has both wave and particle properties. Now there are some results that we have derived from this de-Broglie equation. Now the first result that we have derived from this equation is the wavelength is inversely proportional to the momentum, or the wavelength of a moving particle is inversely proportional to its momentum. So if we have a particle that has high speed, or that is moving with a high speed, it has high value of momentum, in that case wavelength will be small, right? Point number 2 that we have concluded in by this equation is, if v is equal to 0, the speed is 0, then in that case lambda is equal to infinity. Now this implies that waves are associated with material particles only when there is motion, right? When the particle is in motion, when there is some velocity for that particle, only then we get a definite value, a defined value of lambda. Otherwise lambda is equal to infinity. That means no wave associated with stationary particle, right? No wave associated with a stationary particle. Next property that we have conclude here, that there is no role of charge to have that de-Broglie wave associated with a material particle. So to be associated with a de-Broglie wave, that particle need not to have charge, means there is no role of charge need not to have charge. Okay, there is no role of charge in this situation. The last thing is that de-Broglie waves cannot be electromagnetic in nature, because electromagnetic waves are only associated with accelerated charge particle. Since there is no role of charge, so the fourth point that we conclude from here is these de-Broglie waves cannot be electromagnetic wave. The reason is that the electromagnetic waves are only associated with the accelerated charge particle. Okay, so these waves cannot be electromagnetic waves. After this we are going to find the de-Broglie wavelength that is associated with an electron. So if we have an electron, that electron of mass m, right, charge e, and it is moving with some velocity v. So v be the final velocity that is attained by the electron when it is accelerated from rest, and it is accelerated by some potential difference of v volts. So we have considered an electron of mass m, charge e, that is fixed, and we are assuming that v is the final velocity that is attained by that electron, which starts from rest because of the potential difference of v volts. Now the kinetic energy that is gained by electrons is equal to the work done on the electron by this field. So the kinetic energy that is attained by this electron is equal to the work done by that field on the electron. So we can find that kinetic energy I am representing it by K. It is equal to half m v square, and it is also equals to p square upon 2m. This we can calculate easily by multiplying and dividing this formula by small m. Now work done on the electron because of the field is EV. V is the potential difference that we have applied. So this kinetic energy should be equal to this work done. The kinetic energy gained by the electron is because of the work done on the electron by the field. So these two should be equal. It implies we have p square upon 2m, means kinetic energy is equal to p square upon 2m is equal to EV. This is the final equation. If we rearrange these, we get p is equal to under root 2mk, where k is the kinetic energy, or we can also write it under root 2m EV, because k is also equal to EV. So these are the two formula for momentum. Momentum can be written as under root 2mk or under root 2m EV. Now the de Broglie wavelength of the electron means if we have an electron that is moving with some velocity v, that means we have a material particle. So according to de Broglie hypothesis, there must be some wave associated with that electron, and we are going to find the wavelength of that wave which is associated with that moving electron. So that de Broglie wavelength of electron is lambda is equal to h upon p. Since we need p here, that's why we were finding momentum for that electron. So p is equal to under root 2mk, or it is equal to under root 2m EV. So this equation is showing all the results, all the possible values for the wavelength lambda. We can use any of these depending on the question, that what factors we know. Now in this formula there are certain constants. H is Planck's constant, whose value is 6.63 into 10 to the power minus 34 joule second, which is fixed. Again 2 is a constant. M is the mass of electron, that is also fixed and is equal to 9.1 into 10 to the power minus 31 kilograms. Also E is the electronic charge, which is 1.6 into 10 to the power minus 19 coulomb. V is not a constant, it depends that what field we have applied. So lambda is equal to 6.63 into 10 to the power minus 34 upon under root 2 into mass is 9.1 into 10 to the power minus 31 into E, that is 1.6 into 10 to the power minus 19 into V. So if we solve all these factors, we get the final result is equal to 12.3 into 10 to the power minus 10 upon under root V meters. This is an SI system, but this 10 to the power minus 10 meters can be written as angstrom. So we can also write it as 12.3 upon under root V angstrom, where V is the potential difference applied across that field. Okay, so this is the wavelength associated with that moving electron. So that's all for the video. Here we have studied about the dual nature of matter, in which matter is a particle that we have already know, and we have proved that as per the de Broglie hypothesis that there is a wave associated with that material particle if it is in motion. It is only true for the moving particles, not for the particle which is stationary. So that's all. For further videos, stay tuned and keep studying. Thank you.